Good evening dear students, welcome to Maths Bridge course. So in today's session we will be discussing about functions, domain and range. So in the previous class we discussed about intervals and also wavy curve method. I told you the utility of wavy curve method, that where we will be using wavy curve method and how it will be beneficial for us to solve the questions of application of derivatives and also from the chapter of functions. Now when we talk about functions, first we will learn what is functions, that is the basics of function we will understand, and then we will understand what is domain and range. And after that in the upcoming classes we will be learning about various important functions like modulus functions, greatest integer function which is also called step function, and also fractional functions, and also logarithmic functions, and also exponential functions, that is e power x, all these things. Okay, they are very important. And why we have to study functions in a proper way, or why you have to understand the basics of function? It is because, see here, when you talk about the functions, see here, it is very important to know functions because it will be highly useful in the chapter of what? Limits, continuity and also differentiability. Okay, differentiability. The chapter will have limits of a function. For that you should know what is a function, right? And also when it comes to continuity of a function we will study. And once the function is continuous, then it is differentiable also. Okay, and all differentiable functions are continuous functions, but not the other way around. All these things we will discuss when I talk about continuity and differentiability chapter. But to understand continuity and differentiability, you should understand the basics of function first. Okay, so that's why we are learning the functions topic. And also in your 11th and 12th standard, you also have the chapter of sets, relations and functions as a separate unit itself. Okay, so for that the basics of functions is very important. Now see here, when we talk about the basics of functions, what are the things that we have to know? Okay, so we will be studying about what? Functions introduction. Okay, functions as a set of ordered pairs, vertical line test, domain and range of functions, algebra of functions, different types of functions and their graphs we will be studying in the upcoming classes, problems on some unique problems or some examination questions on functions we will be doing it. Okay. Now what is a function? Okay, before going to this figure, I would like to discuss certain very important points when it comes to functions. So see here, when we talk about functions, observe carefully. Functions as a topic comes from sets. Okay, functions as a concept is arising from sets. Okay, why I am talking about sets? Already we have discussed about sets in the previous classes. Those who not watched, please go through that. Okay, sets. Suppose we are having two sets A and B. Let's set A be what? Sets basics you have studied in your high schools also. Set A, let it have the elements be A, B, C. Set B, let the elements be 1, 2, like this, some random set. The Cartesian product of this set, okay, gives us an ordered pair, that is called as what? From there arrives the concept of functions. So let me tell you what is this Cartesian product of these sets. Cartesian product of these sets gives us then ordered pair. From there arrives the concept of what? Functions. Okay, so first you should know sets. From that Cartesian product of these sets gives us something called relation. From relation arises functions. So Cartesian product means what? Sir, you are telling me Cartesian product. What is this Cartesian product? If you ask me, it is nothing but we are doing A cross B. Okay, this gives us an ordered pair. Okay, this gives us an ordered pair. What I can write? Ordered pair of what? A1, A comma 1, A comma 2. So first what we will write? A comma 1. Then what we will write? A comma 2. A comma 1, A comma 2. Then what we will write? B comma 1, B comma 2. B comma 1, B comma 2. Okay, B comma 1, B comma 2. Then you will write what? C comma 1, C comma 2. Ordered pair of C comma 1 and C comma 2. C comma 1 and C comma 2. So this is what the Cartesian product we got. This is what we got, the Cartesian product. From this Cartesian product, I will apply some condition. So this is what? From the sets, the Cartesian product we got the ordered pair of two sets we got it. From this what we will do? We will apply some condition for this. Okay, I don't want everything. From this I want only the elements which are having odd elements, which are having odd numbers. Okay, if I apply a condition, if I apply some condition to this, like if I want only odd elements or even elements, here I am applying odd elements. Odd elements means what? Here I will be getting odd elements. What are the odd elements here? This is an odd element because it is having one. This is an odd element. This is an odd element. So from this Cartesian product itself, I will get some another subset. Okay, what I will get here? A comma 1, B comma 1, and I will get what? C comma 1. Okay. So if you apply some condition to this Cartesian product, what you get? That is called as what? Relation. This is called as what? This is called as relation. This is called as what? Relation. Okay, Cartesian product you got. For that you applied some specific condition. The condition is what? I applied odd elements. Okay, then I got what? Something called relation. For this again, if I apply some condition, if I apply some special condition, what I get is a function. For this again, if I apply some condition, what I get is a function. Now let me apply some condition for this. What is the condition? I want only elements, only A elements. I want only A elements. I want only A elements. That means what? What I will get? Only A comma 1 I will get it. Only A comma 1 I will get it. That is, I am applying the condition again. This is called as a function. This is called as what? A function. Okay, this is called as what? Ultimately what we get is called as what? Function. Okay, so clearly let me put it in a flowchart way. So sets are there. For that you apply what? Cartesian product. Cartesian product. Okay, for this Cartesian product you apply some condition. You apply some condition. What you get is what? A relation. You apply some condition for this Cartesian product. Okay, what is the condition I apply? Odd elements there. So you apply some condition for this special condition. That means out of this Cartesian product, everything I don't want. Suppose you go to a hotel, everything in the menu you don't want, only specific things you want, which is favorable to you. That is a relation. What you get here is a relation. And when you see, there is a menu, in that you want dosa. You ordered some dosa. In that dosa also, you will apply some condition. You will say that I want butter more, I don't want oil, put less oil. Okay, then you will tell what? Some specific condition again. Okay, some specific condition again. Then finally you will get the dosa which is having less oil and more butter. That finally what you get, that is called as what? Function. That is called as function. Understood? So from sets arise the concept of what? Function. That's why function is called as what? Function is called as ordered pair of sets. Okay, ordered pair of sets of AB we call it. So this is the concept of functions. This is the concept of functions. Again in simple terms I will be telling what is a function. Now see here. If you take up, just a minute, what is that we have here? So see here, that is what I told you previously. Same thing is given here. What they are telling? Function is a set of ordered pair. A function, okay, is a relation from A to B is considered as a function. Relation from A to B. A is what? One set. B is what? One set. I told you. Okay, a relation. From sets you will get relation. From relation you will get what? From relation you will get what? Functions. Okay, that is what I told you. See here, some sets you will get relation. From relation you will get what? Functions. So if you focus here, a relation that is denoted from set A to set B. Set A to set B is called a function. If every element in A has a mapping, what is this mapping? I will explain, don't worry. I will put it in simple terms. Every element in A has a mapping, and also every element in A has a unique mapping. So see here, new terms are coming which are not studied in 10th. Okay, so as a mapping, they are telling every element in A has a mapping. Then they are telling every element in A has a unique mapping. Every element in A has a unique mapping. What does this mean? Okay, every element in A has a unique mapping. What does this mean? Okay, see here, what does this mean? Okay, let me put it in a simple terms. They are telling there is a relation, okay, A to B. Every element in A has a mapping. That means we should say simple terms, what these two conditions only should be satisfied to be a function. What is this two condition? I am simplifying it. So every element or all element, every element or all element or all element, every element in set A, every element in set A must be must be connected to, what is this? Must be connected to some element in set B. Must be connected to some element in set B. Every element in set A must be connected to some element in set B. Okay, what I am telling, what I am using the word connected. From this connected only second condition arises. Okay, connected. Okay, this connection must be unique. 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 This is what it means. This connection must be unique. That is what they are telling here. That is what they are telling here. They are using the word mapping. What is this mapping? I will discuss. Okay, what is this domain, codomain? I will come back to it. I will come back to this slide again. Now see here what I told, every element in set A must be connected to some element in set B. Okay, this connection must be unique. This connection must be unique. This connection must be unique, they are telling. Okay, so let us take an example for this. Okay, let me give some example for this. So see here, there are two sets. Okay, let this be set A. Let this be set B. Let this be set B. Let us use some real life example. Let here be, let set A represent what? Children. Let set A represent what? Children. Okay, set A represents what? Children. Set A represents children. Set A represents what? Children. Set B represents what? Women. Set B represents what? Women. I am not telling mother, I am telling women. Set B represents what? Women. So the function, what is the function talking about? Function is talking the relation. Function is talking about the relation of what? Child of. This children is a child of whom? They are asking. Okay. So here there will be number of elements. Set A there will be number of elements. So let us write the number of elements 1, 2, 3, 4, 5, 6, something like this we will write it. Okay, set A. Then similarly set B. Set B also has number of elements. Let us write it like A, B, C, D, E, F, okay, G, H, something like this we will write it. Okay, something like this we will write it. Now what did I tell you? Every element in set A must be connected to some element in set B. Every element in set A must be connected to some element in set B. That means this should not be left empty. It should definitely be connected to some element in set B. So I will connect it like this. See here, this goes to this. Okay, this goes to this. This goes to this. Okay, this goes to this. This will go to this, and this will go to this. This will go to this. Okay. Now see here. Observe carefully. What happens? Okay, you can leave, not a problem. Okay, so observe carefully what happens. This 1 and 2 are there. This 1 and 2 are there. This is having, what is that? A as this. What? A as this. A as the element in B. A as the element in B. This one element as what? This child 1 as A as the mother. That child 2 as A as the mother. That is totally possible. So here 3 is having the mother B and 4 is having the mother C. Okay, this child 4 is having the mother C, and child 5 is having the mother E, and child 6 is having the mother D. So each and every child is having a unique mother. So that means what? See, first of all, every element in set A is connected to set B. Yes. See, nothing is left out here. In set A, focus only on set A. Everything is connected to set B. Yes, it is connected. Nothing is left out. Suppose I write 7 here. It is left out. It should not be left out. Nothing should be left out. Everything should be connected in set A. Okay. Next they are telling this connection must be unique. This connection must be unique means, now for example, instead of this, if I write like this 2 is here. Okay, this A is here. This 2 is having mother A. That is totally okay. This A is having, or 1 is having the mother A, and also 1 is also having the mother C. If I write it, see, focus on 1. 1 is the child of A. 1 is the child of C also. If I say, that means that mother of child, okay, mother of the child 1 is not unique. It cannot have two mothers. See, 1 is having the mother A and 1 is having the mother C. Okay, that means it is not unique. 1, child 1, look at this child 1. This child, okay, 1 is the child of A, and 1 is a child of C. That means what? It is not unique. Okay, it is not having a unique mother. It should have only one mother. It should have only one mother. So this connection is wrong. We cannot write like this. But look at this. 1 and 2 are having the same mother A. So see, 1 is having the mother A and 2 is also having the mother A. That is totally correct. That is totally possible. Why? Because A is a mother. Mother can have 2 childs, not a problem at all. So 1 is having a unique. This connection must be unique, they are telling. This connection must be unique. Yes, it is unique here. 1 is having A as the mother, and 2 is also having A as the mother, and 3 is having B, 4 is having D, and 6 is having D, and 5 is having E. Okay, so totally it is connected. So all the elements in set A are connected and everyone is having a unique connection. So the children are having mother, not a problem. But they have not told anything like every element in set B should be connected. No, they have not told like that. So F, G, H can be left empty like this. F, G, H can be left empty like this. Why? Because they are women, they may be mothers, but they may need not have child. They may not have child. So set B is what? Totally fine if it is not connected also. If it is not connected also, it is correct. If it is not connected also, it is correct, set B. But every element in set A must be connected. Every element in set A definitely must be connected. Okay, clear? So every element in set A must be connected. Got it? So that is the first condition, and every element in set A must have a unique connection. It should have a unique connection, that is unique image. So what we call here, this is called as image. This is called as image. What we call here, we call it as pre-image. We call it as pre-image. So also this is called as, what we call is set A, we call it as what? Domain. We call it as what? Domain. There comes the word domain. This is domain. And what we get here, we call it as what? Codomain. What we call here, we call it as what? Codomain. So see here, this set A elements are called pre-image and it has unique image. So set B elements are called as what? Image. And other word, very important word we discuss. So set A elements are called as what? Domain. And set B elements are called as what? Codomain. From codomain arrives the word or arrives the concept of word range. So in codomain, what are the elements in codomain? Everything that is in set B. Everything that is in set B. So out of this, what are the elements in set B that are connected? So see here what I am telling. Set A is called domain. Set B is called as codomain. In codomain, all the elements are connected? No. Most of the elements are connected. Some elements are not connected. Only the connected elements. Only the connected elements. What are the? See, codomain is having set B. Complete set B is called as what? Codomain. Out of this set B, what are the elements which are completely connected? Connected to set 1 or set A. That is A, B, C, D, E. They are connected. That is they are connected. That is A, B, C, D, E. They are what? They are connected. They are connected with what? They are connected with set A. Okay, they are connected with set A. But F, G, H are not connected. So they are part of the codomain, but they are not connected. So what are the elements in codomain which are connected? They are called as what? They are called as range. 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 So range is what? Part of codomain. Part of codomain which has a pre-image or connected, which is connected to pre-image. Pre-image means what? To the elements in A, which is connected to pre-image. Codomain elements are called as what? Image. So this image which is having a pre-image, okay, they are all called as what? Range. The remaining elements you write it as it is. They are not part of the range. So it is a codomain. In codomain, what are the elements that are connected? They are called as range. So we can say what? Range is a subset of codomain. Range is a subset of codomain. We represent it as B. Codomain we represent it as capital B. Range is a subset of codomain, but I will not say proper separate. I have written equal because if I remove FGH here, this codomain and range will become equal. Whatever is in the range or whatever is in the codomain, everything will become range. So if I remove FGH, whatever is in range is nothing but equal to codomain. So understood. So range is a subset of codomain. I can write it. So clear. So this is the things you have to know when it comes to codomain and also domain. Now see here, set A entirely should be domain and set B is called as codomain. In codomain, the connected elements, we call it as what? Range. The connected elements we call it as what? Range. I hope you would have got some idea now about what is a function. Okay, what are the two conditions that should be satisfied to have a function? That is, all the elements in set A should be connected. Okay, that connection should be unique. That means an element in set A cannot have two elements in set B. That means it cannot be connected to two elements in the set B. But an element in set B can be connected to two elements in set A. That is possible. So see here, it should be unique. It should be unique. See here, 1 is connected to A, 2 is connected to A. That is not a problem. But 1 should not be connected to some other element again. From here there should be one connection. From here there should be one connection, no problem. But if 1 is connected to A and 1 is connected to EF or 1 is connected to E, it should not be the case. So this child should have only one mother, and that mother should be unique. And here nobody should be left out. That means there should not be an orphan. Okay, clear? The child should definitely have a mother. But here this woman or this mother need not have child. Okay, it can be left out. It can be left out here. Okay, which are left out? They are part of the codomain, but they are not part of the range. Some more examples we will take it for you to understand better. So look at this. Look at this example, all of you. So we are having set A and set B. So what is a domain here? Everything in set A is a domain. Correct now? This is completely domain. Okay. Whatever is here, this is completely codomain. This is completely codomain. So domain is what? Domain is set A. Domain is set A. Set A is codomain. Codomain is what? Codomain is everything that is in B. Okay, everything that is in B, that is set B is codomain. That is A is what? 1, 2, 3, 4. B is what? X, set of, what is this? X, Y, T, W. Okay. Range is what? Out of this codomain, what are all connected? What are all connected? That is range. W is not connected. Leave that, and remaining thing which are connected, write down, that is range. So here what is connected? So see here, X is connected, Y is connected, and T is connected. And T is connected. This is range. First of all, this is function or not? Yes, it is function. Every element in set A is connected, and every element is connected to a unique pre-image or unique image. 3 is T and 4 is T, and 3 is not going to T and 3 is not going to W. Okay, 3 is going to only 1. Okay, 3 is having only one mother. So this is correct. But a mother can have two child or two or more child. That is also fine. So see here, let us take some examples. So to say which of the following is a function or not. Which of the following is a function or not. Look at this. This child is having mother here. This child is having mother. This child is having mother here. Is this a function? Is this a function? First of all, tell me, is this a function or not? Is it visible? Yes, it's visible. So first of all, is it a function? Yes, it is a function. What about this one? See, every element in set A is connected. Yes, it is connected. Is it having unique? It is connected to unique. That is, yes, A is connected to 1. A is not connected to anything else. B is connected to 1, but B is not connected to anything else. C is connected to 1, but C is not connected to anything else. So it is correct. So 1 is the mother of A, B, C. That is totally fine. So yes, it is a function. Yes, it is a function. Now see here, what about this one? Third example, look at this. Is this a function? Is every element in A connected? No. C is not connected. That means this is not a function. This is not a function. This definitely should be connected. This definitely should be connected. Now see here. Look at this fourth example. Is it a function? Every element in set A is connected? Yes, it is connected. Now is it connected uniquely? No. See, A is having 1 as the mother and A is having 2 also as the mother. It cannot be. A is having 1 also as the mother, but A is having 2 also as the mother. So it is not unique. So it is not a function. It is not a function. Clear? Understood? With these examples, did you understand what is a function? Now, let us take some more examples before we go to vertical line test. Let us take some more examples. Just a minute. Let us take some more examples before we go to vertical line test. let us take up some questions from the examinations that have come. Now, instead of giving like this, let me give the questions like this. Now tell me whether it is a function or not. Question is, check whether it is a function. It is a function. Check whether it is a function. Okay. It is given f of or relation a to b, relation a to b. Okay, is given where set A is what? Set A is given as 3 4 5 6, 3 4 5 6, and set B is given as what? Set B is given as 7 8 9 10 11 12. Okay, this is the question. Okay, and R is given as, that is what? After the connection, that is the function is given as what? That is the connection, that is function is given like this: 3 8 4 8, okay, 5 10 6 12. This is one question. Okay, this is one question. Let me take one more question. One more question. One more question. We have to check whether it is a function. A to B is a function. They are telling. We have to first check whether it is a function and then write domain and range. Okay. A is given as what? 1 minus 1 3 7, and B is given as what? B is given as 1 9 49. What is the relation saying? Relation is equal to set of x comma y such that, okay, x belongs to A and y belongs to B. Okay, what is the relation they are telling? And y is equal to x square. Y is equal to x square. Okay, y is equal to x square. This is what they are telling. Okay, this is what they are telling. Now see here, observe carefully what they are telling. So these are the two questions we have to do it now. Now based on this, observe carefully. First question. So check whether it is a function, and also write its domain. What is its domain? What is its codomain? What is its range? We have to write for this function. First check whether it is a function. So see here, set A is there, set B is there. Okay, set A is there, set B is there. It is given, connection is given like this. Connection is given like this. So let me write it in the form of this way. Okay, let me write it in the form of this way. That is the ordered pair. Let me write it like this way so that you understand better because this is the way I told how the function will exist. So let us take this way only so that you understand better. Just a minute. So we will do the mapping now. Set A, set B is given. Set A, what are the elements we are having? 3, 4, okay, 3, 4, 3, 4, 5, 6. Set B, what are the elements we are having? Set B is, we are having the elements 7, 8, 9, 10, 11 and 12. So these are the elements we are having here. Okay, these are the elements we are having here. In this relation, what they are telling? 3 goes to 8. So 3 is going to 8, yes, fine. 3 is going to 8. 4 goes to 8, yes, 4 is going to 8, fine. 5 is going to 10, 5 is going to 10, okay. Then 6 is going to 12, yes, fine. Now see, to check whether it is a function, observe carefully. Is every element in set B connected? Yes, it is connected. 3, 4, 5, 6, everything is connected, fine. First condition is satisfied. The second condition is the elements having unique image. Yes, 3 is having 8 and 3 is not having something else. 3 is having only 8. 4 is having 8 but 4 is not having anything else. 4 is having only 8. 5 is having 10 and 5 is not having something like 9 or 7. Yes, it is only having unique. 6 is having 12. Yes, it is correct. 6 is not having 11 as the mother. 6 is not having 9 as a mother, 6 is having only 12 as the mother, 6 is not having another mother like 11, 9 or 7, 8. So it is having unique image. So definitely it is a function. So it is a function. It is a function. It is a function. Okay, it is satisfying the two conditions which I told you for the definition of function. Now what is the domain? Everything in set A is a domain. Domain is what? Set A. Everything in set A is a domain. What is that? 3, 4, 5, 6. What is codomain? Everything in set B. This is also called what I told, pre-image. This is also called image. Image is what? Codomain. Pre-image is what? Domain. So codomain is what? What we have to write? Codomain means we have to write, that is set B, complete set B. That is what we are having, 7, 8. What we are having, 7, 8, 9, 10, 11 and 12. So these are all what? These are all what? Codomain. Now what is the range? So out of the elements in codomain, those elements which are connected to set B, they are called as range. So here what is connected? 8 is connected. What else is connected? 10 is connected. 12 is connected. So range means what? Range means we will write what? Only connected elements, that is 8, 10, 12. So that is what? Here we are having 8, 8 is here again, 10, 12. This itself is range. This itself is range. Clear friends? This is the domain, codomain, range. First of all we understood that it is function. We checked whether it is function. Yes, we got it, it is a function. Then we found out its domain, codomain and range. Clear? So let us go to the next question friends. Let us go to the next question. Okay, in the next question, A to B is a function. First we will check whether it is a function. Okay, but they have only given it is a function, but still we will check it. Okay, so A is given as what? 1 minus 1, 3, 7. Okay, and B is given as what? 1, 9, 49. Okay, 1, 9, 49. So x comma y, ordered pair of x comma y is given. X belongs to A and y belongs to B. Okay, and they are telling y is equal to x square. Y is equal to x square. So they are telling y is equal to x square. So see here, we are having x here, we are having y here. Y is equal to x square. We are having here. So see here, x belongs to A. So all the elements in set A, write it here, 1, minus 1, 3, 7. Okay, write it here. Okay, y is equal to x square. So on squaring 1, what we should get? Elements in B. Y belongs to B means we should write what? 1, 9, 49. We will write it. 1, 9, 49. We will write it. So y is equal to x square. That means what? 1 if you square it, what you will get? 1 only. Minus 1 if you square, what you will get? You will get plus 1. 3 if you square, what you will get? 9. Okay, 7 if you square, what you will get? 49. Yes. So see here, every element in A is connected, or every element in X is connected? Is every element in X connected? Yes, it is connected. Yes, it is connected. So first condition is satisfied. Now is it connected uniquely? That means one is having only one here. Okay, only one image. One is not having some other thing as an image, only one is the image. Minus 1 is having only one as the image, not something else as the image. 3 is having 9 as the image, and 3 is not having something else. 3 is not having 9, 3 is not having 1, 3 is not having 49. All the 3 are not the image. Only one means that is it is having unique image. The 7 is having only 49. So definitely it is a function. So definitely it is a function. It is a function. Okay, it is a function. Okay. Now if they ask domain. Domain is what? Domain is entire set A. Domain is the input. Entire set A, that is what? 1, minus 1, 3, 7. This is the domain. Okay. Codomain is what? Codomain is everything that is in set. That is everything that is in set B. This is set B itself. So that will be what? B will be what? 1, 9, 49. Okay. This is codomain. Range means what? Those elements in set B which are connected. Here every element is connected. So range is nothing but equal to here codomain, that is 1, 9, 49. 1, 9, 49. So we got the codomain, domain, codomain and range. Clear friends? This is how we can get the answer to this question. First we check whether it is a function, and then we got what? We got codomain, domain, codomain and range. Domain, codomain and range. Okay, clear? Now domain, codomain and range. Okay. Now if I write, see here, y is equal to f of x. If I write it, y is equal to f of x. If I write it, okay, so you can see in many questions you will get it like y is equal to f of x. What does it signify? Y is equal to f of x. If I write it, what does it signify? each of it has a meaning. So here, see here, this this thing, see here, y is equal to f of x if I write it, this y is what, this what is this y, what is the meaning of this x, what is this f, okay, what is this f. Now see here, y is equal to f of x if I write it, this x is called input, this x is called input, this input is nothing but what, this input is nothing but domain, this input is nothing but domain, okay. This y, what we get, that is outcome, we are getting output, this is what, output, this output is called as what, output is what, called as what, codomain. In that what are all connected, we call it as range. Codomain, usually it is range, which is connected, we call it as range, codomain. Now this f is what, this f is the function, this f is the type of function, okay, this f is the type of function, this function can be anything, it can be modulus function, it can be greatest integer function, I will be talking about this, this can be log function, this can be exponential function, anything like this, this can be trigonometric function like sin theta, something like this, anything it may be, anything it may be, this is the function, this is the function, this is the function, okay, clear. So this is the basic meaning of this, this is the basic meaning of this. Now let us come back to this figure, what is a function. So see here, what is a function. Observe this, whatever we give the input, okay, whatever we give the input, based on that we will get the output, okay, whatever we give the input, based on that we will get the output. Now see here, for example, this function we basically connect, or we basically say this function is a machine, okay, this function we call it as a machine, okay, we call it as a machine, function we call it as a machine. So let us take the example of sugarcane, and using the sugarcane what we will do, we will make sugarcane juice. So here this is a sugarcane machine, okay, so this is the sugarcane machine, you think, sugarcane machine, you think, okay, sugarcane machine. So using this sugarcane machine you will make sugarcane juice, this is the function. Here sugarcane machine is what, function. So here you will put what, the sugarcane, you will keep putting it here, okay, you will keep putting the sugarcane here, you will keep putting the sugarcane here, okay. From this it will get filtered and you will get, what is this, you will get here the juice, okay, you will get the juice, that is the sugarcane juice, you will get what, sugarcane juice. Here it is juice, sugarcane juice you are getting, here you are putting what, sugarcane, here you are putting what, sugarcane, okay. Observe carefully, you are putting what, sugarcane. Now observe carefully, functions, domain and range I am teaching. So see here, this is the sugarcane, this is the sugarcane machine. If you put the sugarcane, you will get sugarcane juice. The sugarcane here represents what? It is the input. It is what? It is representing input. It is representing input. This input itself is what? This input itself we call it as what? Domain. This input itself we call it as what? Domain. Okay. And by keeping this input, we will get what? The sugarcane juice. The sugarcane juice we call it as what? Output. The sugarcane juice we call it as what? Output. This output itself we call it as what? Range, or we call it as codomain. What we get, or we can say this is directly, you can say that output what you get, we call it as what? Range. We call it as range. This is range. What we are getting here is range. Okay, what we are getting here is range. This machine, this sugarcane machine, like I told you, this is nothing but the function. This is nothing but the function. This is nothing but the function. Okay. So for this sugarcane machine as the function, this sugarcane is the input and you are getting sugarcane juice as the output, and you are getting sugarcane juice as the output. Now clearly understand here, this is the sugarcane machine, this is the function. Sugarcane machine is the function. Input is what? Sugarcane. I am getting sugarcane juice as the output. Now for the sugarcane machine, if I put what? Mango, if I put apple, do you think we will get the juice? Definitely we will not get the juice. It will get crushed and we will not get the juice. So that means what? If I put a pumpkin, will I get pumpkin juice? No, I will not be getting it. Why? Because this sugarcane machine will work only for the input of sugarcane. Okay, that means what? This function is specific to certain type of inputs. Okay, you cannot keep anything as input. So domain, what you are keeping as input is depending on the function. Based on that you will get the output. Okay. So if I want apple juice or mango juice, I want juice mixer. Okay, juice mixer. Okay, juice mixer. For this, if I put mango, I'll get what? I'll get mango juice. I'll get mango juice. For this juice mixer, this will be like mixie. You'll get mango juice. Okay, this mango is what? Input, we call it as what? Domain. What we get? Mango juice, we call it as what? Range. And here this juice mixer is the function. Okay, is the function. For this juice mixer, can you put sugar cane? No, the juice mixer will not work. Okay, for this only mango or apple or anything such kind of fruits you can keep. So this function is only working for this kind of inputs. So that means the domain which you are giving input will depending on the function only you can give the domain. Okay, for this sugarcane machine you should use sugarcane, not the mango. So this is the meaning of the function, domain and output. Okay, so that is what we are represented here. Input, there is a function, it follows some rule. That means what? For sugarcane machine, put sugarcane. That is the rule here. So based on that you will get the output, that is what? Sugarcane juice. But if you put mango, you will not get mango juice. Okay, you will get, it will get squeezed and it will be thrown away. Okay, so f of x is given as what here? F of x, for this question, what is this x? This x is what? Input. This x is what here? Look at this one, this x is what? Input. This x is what? Input. I am taking so much time to explain functions because you have to have more clarity. You have to have complete conceptual clarity when it comes to functions. So this input is what? X is what? This input. I told you this x is input. Okay, this f is what? Function. Function is this one. Function is 2x plus 1 is the function. 2x plus 1 is the function. And what I write here? This is output. What I write here now it is output. Input is we call it as what? What? Domain. This is domain. This is what? Codomain, or I'll write it as range. Now observe carefully, when I put input as -2, so what I'll get? 2 is a, what is this? 2 into -2 is what? See, 2 into -2 is what? -4. -4 plus 1 is what? I'll get it as -3. Output I'll get it as what? -3. See, 2 into -2 is -4. -4 plus 1 is what? -3. If I put input as what? -1. So -2 plus 1 is what? -1. If I put input as 0, I'll get 1 as the answer. If I put input as 1, I'll get 3 as the answer. If I put input as 2, 2 2s are 4, 4 plus 1, 5 as the answer. So this is what? This is what? This is what? This is a set of all what? Inputs, that is called codomain. This set of all outputs, that is what? This is completely connected, that is set of all range. That is what we are getting the output, that we call it as range. Clear? With this illustration, I hope completely you have understood what is the concept of functions. What is the concept of functions? Now proceed further. Now to understand functions, one more concept is there, that is called vertical line test. That is called as what? Vertical line test. What is this vertical line test? If you see a graphical method to check if the curve is a function or not. See, you will get lot of graphs in the class 11th and 12th. You will be getting in mathematics, there will be lot of graphs. To check whether this graph is satisfying the given function or not, we will have something called vertical line test. Draw a vertical line at different positions. If it intersects the curve at more than one point, then it is not a function. What does it mean? So let us take the examples here. Now see here, in this example, observe this carefully. If I draw a vertical line, observe carefully, if I draw a vertical line, in each of these examples, see, observe carefully, if I draw a vertical line, it should cut the point at only one point, but not at 2 points. So see here, if I draw this line here, vertical line, if I draw here, see here, it is cutting here also, it is cutting this curve here also, it is cutting this curve here also, it is cutting this curve here also, it is cutting at more than 1 point, it is cutting at more than 1 point. Okay, so definitely this curve is not a function, this curve is not a function. Vertical line means draw one vertical line, that's it, perpendicular line to this vertical line. Now look at this, for this one, is it a function or not? So definitely not. See here, it is cutting here also, it is cutting here also, more than 1 point. So this is not a function, this curve is not a function, this curve is not a function. But look at this one, okay, the curve is this one, this is cutting only at this point, don't consider this is just the x-axis, the curve is only here, this curve is only here, and it is cutted, not cutted, it is got cut only here, okay, it is cut only here, it is intersected only here. Instead of cut, we should use the word, better word is what? Intersect. Okay, it is intersected at only 1 point. It is intersecting at more than 1 point means it is not a function. It is intersecting at 1 point means it is a function. Definitely it is intersecting only at 1 point. Forget about this. This is just the x-axis. The curve is this one. This is the curve. This is the function. So it is cutting only at 1 point. So this is a function. This is a function. Clear? So this is a function. This is clearly a function. Now observe carefully before we go to the question. Let me take one more example to say whether it is a function or not. So see here, we are having like this. Okay, we are having a line like this. We are having this is y axis origin, this is x axis. Suppose we are having a line like this. Okay, now I draw a vertical line. I draw a vertical line here. 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 Is it a function or not? Tell me. Is it a function or not? Tell me. See, definitely it is a function because it is cutting only at this point. It is cutting only at this point. It is cutting only at this point. Nowhere else. Okay, it is cutting only at this point. It is not cutting somewhere here. See, you are just moving the intersecting point. That is, you are just moving the vertical line. You are moving from here. If you are moving from here, if you are moving from here, it is cutting only at this point. So definitely this is a function. Definitely this is a function. Suppose the graph was like this, and if it was cutting here also. Okay, if it is cutting at two different points, here also, here also, here also, here also, here also, here also. So that definitely it is not a function. But here in this case, it is a function. But in this case, it is a function. So see here, look at this vertical line. In this vertical line, where it is cutting at only one point, so it is a function. At this vertical line, where it is cutting at only one point, so it is a function. At this vertical line, where it is cutting only one point, so it is a function. Okay, so this is how you will use the vertical line test. They have given the question also. See, which of the graph is not a function? They are telling not a function. They are asking not a function. Which of the following is not a function? If you observe here carefully, okay, which of the following is not a function? So see here, draw the vertical line for this. For this, if I draw the vertical line, so see here, this is the x axis, y axis, x axis. If I draw the line here, it is cutting here also, it is cutting here also. So definitely it is cutting at more than one point. So it is not a function. Not a function. Yes, it is not a function. So graph 1 is not a function. So first option I can go. But let us check for other curves also. So see here, if I draw here, if I draw here, if I draw here, if I draw here. So it is cutting at this point. Yes. It is cutting at this point. Yes. It is cutting at this point. Yes. So at this point it is cutting, nowhere else it is cutting. At this point it is cutting, nowhere else it is cutting. At this point it is cutting, nowhere else it is cutting. Upside down if you see. Upside down if you see, it is cutting at only one point. Okay, but here if you see upside down, it is cutting at this point, it is cutting at this point, so it is not a function, this is a function. Okay, here same way if I do it here, it is cutting at only at this point, here only at this point, only at this point, only at this point. Upside down if you see, it is not cutting at more than one point, it is cutting only at one point. Same thing goes for here, so definitely it is cutting only at one point, so definitely this is a function, this is a function, this is a function, and this is also a function. Which is not a function? Graph 1. Which is not a function? Graph 1 is not a function. Okay, graph 1 is not a function. Okay, now one more thing, one more concept you should know. So I am talking about functions here, right? So here you should know number of elements. So there are, I told you in sets itself, set A, B contains, let it contain P elements, Q elements respectively. Then number of elements of set A is what? P. Number of elements of set B is called Q. Number of functions from set A to set B. So when we say number of elements from set A to set B, that means, so number of functions, the function is what? Set A to set B. Set A is having how many elements? P elements. Set B is having Q elements. Number of elements from set A to set B is represented by what? Number of elements from set A to set B. You are at set B. Set A to set B. Set B is having how many elements? Q elements. Set A is having how many elements? P elements. From B you have to represent. B is having how many elements? Q. Q you write it down and P you write it at the top. Okay. Q you write it at the bottom and P you write it at the top. Suppose if they ask number of functions from set B to set A. Set B to set A. Set B is having how many elements? Q elements. Set A is having how many elements? P elements. Now you are going from B to A. In A how many elements are there? In A how many elements are there? P. Okay. Whatever elements are this here. Okay, the elements here should come at the bottom, that should be the base. So this will become what? This will become P will come down. What will happen here? Q will go up. Q will go up. Okay, Q will go up. Let us take one more example. Suppose there is set B. Okay, suppose there is, let us take set X. Suppose there is set X. Okay, number of elements of set X, let it be, number of elements of set X, let it be 7. Okay, let there be set Y. Number of elements of set Y, let there be 9. Okay, Now I will ask you a question. Okay, now I will ask you a question. Function, number of functions from x to y, number of functions from x to y, number of functions from x to y, number of functions from x to y. That means what? Whatever the number of elements that are there in y should come at the base. Y, what is the base? Y number of elements is what? 9. To the power of what? Number of elements in x, that is what? 7. So same thing if I ask number of elements if the function is from y to x. Y to x means what? So see here, x how many elements are there? 7. That should come at the base. Y how many elements are there? That is 9. That should come at the power. Okay. 7 to the power of 9. 7 to the power of 9. Okay. See here, based on this they were given a question. Number of functions from set of 3 elements. Number of functions from set of 3 elements to set of 4 elements. Okay. From set of 3 elements to set of 4 elements. To set of 4 elements. That means what? Set of 4 elements means 4 elements should come at the bottom. 4 will be here, 3 will come up. That's all. So these are the number of functions. These are the number of functions from set of 3 elements to set of 4 elements. Set of 3 elements to set of 3 elements. See further, see every machine has some limitation in accepting inputs. That means that machine is what? Having some limitation. Every machine cannot accept every input. Okay, depending on the machine or depending on the function, we can give the inputs. So the set of all acceptable inputs of a machine is called as domain. That means if sugarcane machine is there, you can give only sugarcane as the input. That sugarcane is called as domain. If juice mixer is there, you can give mango, apple, some other fruits as the input. That is called domain. In that domain, you cannot include sugarcane. And the set of all resulting outputs is called as range. So domain is what? Set of all acceptable inputs. Range is set of all possible outputs. Based on inputs, you will get all possible outputs. That is, sugarcane juice you may get, mango juice you may get, or apple juice you may get, depending on that. Okay. Now see here. Observe here carefully. So in this function, here established connection between set of inputs A, B, C, D to set of outputs 3, 7, 8, 0. Here domain is what? Everything that is there in set. This set is domain. This is input. Output is what? This is the output. That is range. Okay, already we have discussed this concept. Look at this question. Okay, please have a look at this question. They are telling what? If f is a function that is given by ordered pair p comma 1 q comma 2 r comma 3, then domain is what? In the ordered pair, if they give whatever is here, this one, this is what? Domain. This is input. Whatever we get here, this is input. This is domain. This is domain, and this is domain. Whatever you get, we get this one, y coordinate. That is, this if we take this as x coordinate, this is what? Domain. If we take this as y coordinate, they are what? Range. This is range, this is range, this is range. If I put it together, domain is what? Domain is the set of p, q, r. Range is what? Range is 1, 2, 3. So that is what? So the domain is option B. Domain is option B. Clear, friends? Domain is option B. Like this, they will ask a simple question. Okay, domain is option B. Look at this. From the same question, another type of sub question they have asked. If function is defined by this, then which of the following is true? I told you, whatever we write domain, okay, it is called as what? Pre-image. And whatever we get range, this is called as what? Image. For example, this will be pre-image. And what will this be? This will be image. Correct, na? This will be image. Now look at these options. 2 is the image of Q. Then which of the following is true? 2 is the image of Q. Yes, correct. R is the pre-image of 3. Yes, this is the pre-image. 2 is the image. Yes. 2 is the image of Q. Yes, it is correct. R is the pre-image. Domain, whatever we read domain, that is the pre-image. Yes, this is also correct. 1, 2, 3 is the image of F. 1, 2, 3 is the image of F. That is 1, 2, 3. They are what? Range. Range means what? I told you. Range means I told you it is image. R is the image of F. That is also correct. So which of the following is true? All the above. Which of the following is true? All the above are correct. All the above are correct, friends. All the above are correct. Okay. All the above are correct. Now see here, algebra functions. So if you take algebra functions, for any function, if you have a scalar multiple, that is, if you have something like c of f of x is a function, if you are having c of f of x, if you are having a function, this c you can remove outside and you can write function f of x like this. Okay, that is if you are having 2 times f of x within like this. You can write it as what 2, you can take it outside, you can just write 2 times f of x inside. Okay, that is the scalar multiple. Addition subtraction of functions, see, we are having f of plus or minus g. F plus or minus g of x, you can write it as what? F of x plus or minus g of x. See, f of x plus or minus g of x. So, f and g are two functions. Addition or subtraction of two functions can be written as what? Addition or subtraction of two functions can be written as what? First function plus or minus second function. Multiplication also same. F of g of x can be written as what? F of x into x, or g of x into x can be written as what? F of x into g of x, or you can write it as what? G of x into f of x. Nothing but the same. Division also same. F of g by f by g of x. F by g of x can be written as what? F of x by g of x. But this g of x should not be equal to 0. That condition is what? This denominator is what? G of x should not be equal to 0. Otherwise, it will become not defined. So this is the algebra of functions. This is the meaning of algebra of functions. Now see here, they have given if a 1 comma 2 such that function is defined from a to b, f of x is equal to 2x plus 2, and g of a, that is a to c, g of x is equal to x. G of x is equal to x. Find the range of f of g, f plus g. Find the range of f minus g. Find the range of f into g. Find the range of f by g. So let us find out first one. Okay, let us find out this one enough. For f plus g. F plus g we have to find out. F plus g if you have to find out, f is what is given? F is given as what? 2x plus 2. Okay, f is given as what? 2x plus 2. A is what? 2x plus 2. So f is what? 2x plus 2. Okay, g is what, friends? G is what? X. 2x plus 2 plus x. Okay, f plus g of x is what? 2x plus 2 plus x. That is nothing but what? 3x plus 2. 3x plus 2. Now I have to find the range, means first input is what? A is having 1 comma 2. A is having 1 comma 2. First input is what? 1. If I put 1, I will get what? 5. If I put 1, I will get what? 5. If I put 2, I will get what? If I put 2 in this, I will get what? 3 2s are 6. 6 plus 2, 8. Okay. So the range of f plus g is what? 5 comma 8. Range of f plus g is what? 5 comma 8. This is the output. Range of this is what? 5 comma 8. Okay. Similarly, you can apply for what? Similarly, you can apply for f minus g, f into g, f by g. Very simple, which you can do by yourself. Okay. Similarly, you can apply for this. So I will wind up the class now. I think the basics of functions is clear to you. You should have more clarity here. Okay, when it comes to the basics of function, you should know what is a function. I told it arrives from set Cartesian product. In that some special condition, if you apply, you will get a relation. In that relation, understand the example of dosa. Okay, in that relation, if you apply some special condition, you will get a function. Okay, I told the example of what is that? Women and children also, to understand what is a domain. First, what is a function? Domain, codomain. In that, whatever is connected, we call it as what? Range. And also, I gave the example of machine, sugarcane, machine, sugarcane juice. So, input, domain, output, codomain or range. All the acceptable outputs, we call it as what? Range. Okay. And the machine itself is the function. Clear, friends? I hope the definition and the meaning and the concept of function is clear to you. Okay. In real life, example also I gave. What is a function? All these things. In tomorrow's session, we will be discussing what is a domain. Okay. How to find the domain. We have already understood what is a domain. We will understand how to find a domain of various functions. Okay. Of various functions, we will find out the domain, and of various functions, we will find out the range. How to find out the domain, we will learn the steps involved and also the steps involved to find out the range. Okay. Clear, friends? Domain is what? Input. And range is what? Output. All these things we will be learning in the tomorrow session. Clear, friends? Thank you. Let's meet in the tomorrow session. Take care.